Can the people connected at home hear me?
Yes, hello.
Hello. We had some
Professor can hear you.
You can, thank you. So I try to change the camera now. Just wait 1 second. Ok. Impostazioni. Sorry, I just speak in Italian for a couple of minutes, then we'll switch into English. So, microphone, okay. There is... Okay, where is the camera? Is this one? So if I put like this, if I go there, okay. 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 So welcome to our second class. I see 25 people connected online. Can you, before I start, one practical things. Someone just told me that the recording class of, we did our class on Monday, right? Of Monday, the audio was not good, according to guests. We are met guests. So the audio was not good. This time I'll make a check, but I want to add something about. I want to add something about, say, recording of classes. Recording is not a substitute of the class, which means, okay, I can attend the class a given day. I have no problem. I have the recorded one. No, it's not like that. The recorded class is a substitute. Is a complement of the class we make, which means now, of course, I understand that rational people, intelligent people can use it like a substitute. If I can attend the class, I have the recorded one. But I want to say you that this is not the way it works. So please, when you have a problem with, I will try to do my best for having the recorded class working, because if we record, the recorded class must work, of course. But let's try to avoid to say, oh, professor, the class recorded on March blah blah doesn't work. It's just something I'm granting to you. I'm not obliged to, I didn't want actually to, I understand that on 2020, I can understand that on 2021. I have some problems in 2022, but not because just because, I mean, it's dangerous. Recording classes is a dangerous thing because we are not online Pegasus, we are not, we are University of Bologna, okay? University of Bologna is not an online university. Now we have to, we understand that we are living difficult times, so I am open to record our classes just to facilitate your work. but recording must not be an additional problem I have. Okay? Okay, then there is something also, another practical stuff thing I want to tell you, which regards our class on 28th of February. It will be a Monday. Since I'm going to have a surgery on 28th, for that Monday, I'll write to the secretary, so we are not having the class. What about that week? Because there will be another class. So they told me that I should recover very quickly. I go to the hospital just one day. Well, imagine I go to the hospital 20 hours, and I should be 12 hours. I should be out. I go in the morning. I should be out in the evening. So in principle, I should be able, they say, to teach the day after, but I don't know whether that is the case. So the arrangement is like this. We're not having our class on Monday 28th February, for sure. Then we have a mailing list where we can interact, and I will say whether we have two options. Basically, the first one is that we do our class as we are doing here. I'll come to the class. Another option is that I will make the class entirely online for that specific day. Say we should have 20. Our next class will be on the 1st March, right? So the 1st March could be entirely online, could be something like this, a hybrid way, or could be that we have to recover the entire week. That is the situation. I'll keep informed. The only certain thing is that I cannot teach on 28th February. Okay, so but we'll recover. We'll find a way of recovering it, and the challenge is whether on March 1 we can do our class like this. Okay. So I go to on Panopto, and I hope this time it is working. I will check at a given point whether it is recording, because Monday, I just realized at the end of the class that Panopto said, well, audio is not wonderful. There was someone of you with me in that moment. Oh. So let's I have to say Chrome is the, okay, let me, first of all, I share the screen for the students at home. Can you see my screen now?
Yes.
Yes.
Thank you very much.
Yes.
Yes, thank you. Now, I have to say Chrome that it is the yes, and now at the end I could manage. Okay, and let's try again with start recording, Panopto. Okay. And I also sent you an email this morning where I sent. We'll discuss very quickly the solution of the exercise. Just a few words, and also I sent you 2 Gretel data sets because today I would like to start also putting our hands on the data. I told you that it will be a mix between the 2 things, but theory will have priority, but I also like to do empirical things. But I will repeat it all times, several times. we have to do empirical. When we do empirical analysis, we have to be conscious of what we do. Okay, so what is that? This should not be here. Anyway, so this is class of applied econometrics, metrics of Wednesday 16. I don't know what I should not see this. I don't know why, but anyway, I start recording.
You could try to change the video option.
Okay, thank you all. So very okay. No, not completed. Eliminate. Okay. So
instead of B4K something and
nothing. Nothing. Okay.
And to be sure about the audio, the mic should be the same that Teams is using.
Okay, that's very good. Thank you very much for this suggestion. So let me check the one in. Oh, those are. Thank you very much. So the microphone, it's here, impostazioni. Okay. So it's Jabra, right?
Yes.
Jabra speak. Okay. So Panotto should also find Jabra.
Mm-hmm.
Audio. Jabra. Okay. Now I go. Thank you very much. I really appreciate this. Okay, recording. So there is no, apparently, there is no indication by Panopto that the recording is not good. The quality is not good, but I will, during the break, maybe I try to give, I will check it. So welcome to our class of applied econometrics. Very quickly, let me open solution. Thank you very much to all the students who have sent me their solution to the problem. I just want to very quickly to full screen, just to make the point. Okay, the exercise was something like this. I stand up and can the people at home see me now? Can you see? Yeah, okay. So if I point on the blackboard here, you can see me. Probably not the equation, but you have the equation. You see, you have the equation on the PC, right?
Right.
Wonderful. Okay. So linear model. Let me say that the exercise. The point where you find the exercise on the slide, it was before our interpretation of a linear regression model as a model for conditional expectations. Okay, so we have to compute this object here, this ratio, denominator covariance between two random variables, denominator, say square root of a variance, and we statisticians call square root of variance standard deviations. Okay. Now let's focus on denominator, and so I have to compute the covariance between two objects. What I have done, I plug in the expression of yi, this guy here, and then I go by applying linear properties of the covariance operator. And we have written the linear properties. Even if we don't remember that from our, let's say, 3 years course, even if we don't remember that from the crash course with Professor Tassinari, blah, 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 we said that Monday. So it's a linear operator, so what I do, I compute covariance xi, the constant is not a random variable, so I just don't consider it when I consider variation of constants. I just consider random variables, so I do covariance between this guy and this guy here, and I get this because covariance xi collapses to the variance, okay? And then covariance between this guy and ui. Okay? It is this term, and I pointed out this one is not necessarily zero unless you say, okay, I am in the regression model, I am under the interpretation of the regression model that we saw in our class, so I can kill this term. Otherwise, this term will be different from zero. Okay? And we said that the point, what was the point of our first class? Was that in the absence of an hypothesis, people in the room. What does it mean that we have people in the waiting room? Okay, this is one. Okay, this is the Erasmus student, so I will admit him. Okay, so slides. I would expect someone to say, okay, I am in the conditional model we said. In that case, we saw that one implication of conditioning the regression model with respect to the regressors, we said one implication by applying, why do I say an implication? Because we apply the law of iterate expectation. Just look at the slides. It's nothing new. It is in what we have done, which is on the slide, for me, is something not new. Okay? So we just proved that this term can be set equal to 0 in that very special case. Okay? Now, let's focus on the denominator. The variance of y will be the variance of the sum of the three terms. Actually, beta 0 is a constant, so it's a deterministic guy. It's not a random variable, so I don't care about it. So I simply apply the rule that if you have to compute the variance of the sum of random variable, it will be the sum of the variances plus all the times, 2 times interactions between the terms in the sum. So the variance of B1 xi will be, you know, when the expectation is a linear operator. So if I have to shift the constant from expectation, I just say B1, but we have a variance. It is the expectation of squared, so B1 goes outside squared, variance xi plus variance second terms plus 2 times interaction of the 2 terms. And again, this term will be 0 only under very special case. Okay? Only in the particular case in which we make the implicit assumption. For the moment, it is implicit. By the end of the course, we should be able also to test, to check whether we are in that case or not. But most of the time, it's just because we are expert of the problem we are dealing with. We know whether the term can be 0 or not. It will be just a matter of knowledge of the problem, of the phenomenon. That's why we need theory. If you don't have a theory for your problem, if you think I am an expert of anything in the world, okay, you apply all the time OLS and you do mistakes, because we said when you apply OLS this time, this term is equal to 0. But it's not always the case. We made an example, okay? And so summing up, the solution will be, it's quite long, you know. In the numerator we have this expression, in denominator we have this expression. Of course, if we want to kill this guy under the interpretation we set, we can kill this guy, and this expression kind simplifies. Let me say a kind, elegant, smart way of solving the problem under this condition, okay, would be I rewrite correlation between the two variables like a B1 variance xi over sigma y, sigma x. What is sigma x is the standard deviation. What is sigma y, standard deviation. I just don't expand it. because, you know, the expression, the formula, the final formula is this one, which is a very elegant one. Basically, it says that the correlation is this coefficient, this regression coefficient over, say, ratio between standard deviations of regressor over dependent variable. And that's the end of the story. I want to thank all the students who attempted to do it and send me their solution. Thank you very much. Okay? Any question, clarification? Also, Tom, of course, when I make questions, the question is open to all the students. Now we come back on our slides. And exactly, I want to come back to the point where we, organization, we will make a first break around 4 o'clock, okay, 10 minutes, say. Then we'll make a second break around 5 o'clock, 10 minutes, okay? So, full screen. Is it okay for the people at home when I stand up, I go to the blackboard? Or do you prefer me sitting here? Question. Okay. In the absence of any observation, I imagine that everything is fine. So if there is something, please complain, okay? Now, we were at this point. Exactly here. What we said very quickly, let me recap very, very quickly what we said in our first class Monday. We said, okay, guys, we need, when we write a linear model, we can write the model as we like. There is no claim, no statement about causality. It's just putting the x on the right-hand side of an equation is just a convention that we, I mean, and the convention can be justified by the following idea, this one. Okay. Causality runs from the regressors to y. Let me check if it is recording. It seems it is okay. Maybe this. Okay. Okay. We are not lost anything. Actually, I'm starting just now, so it's. But why was it? I haven't. Okay. Anyway. Conditional model. This one, we said, okay, all the time we have in mind a model where causation runs from this way. The correct way of interpreting that is thinking about our regression model as a model for conditional expectations. And the trick, what is the trick? In this model, think about it. We don't have an equation for x. We said, we condition on x. That is all that we know. And if you think about, you know, I made we derived, okay, given that condition, we proved that it holds the following crucial condition, that is, regressors and error term are uncorrelated under that interpretation, okay? Now, we said a counterexample. Do you remember the counterexample where we had this very, you know, I'm not an expert of temperature issues, things like that, but this is very structured. So I had this example, and I said at a given point, okay, maybe if x2 is the sea level temperature, it is the case that shocks to the sea level temperature are not uncorrelated with, say, shocks to outside temperature. And in order to do that claim, if you think about it, we basically I specified an equation for sea level temperature. So you can see I have an equation for X. I have an additional equation. I have an additional idea, additional model for that. So my model is larger than simply I condition on X and everything is okay. So I'm moving to, I am implicitly moving from a single equation to an additional equation. That is an additional equation. And that is where the endogeneity problem stems. Okay, but we'll discuss this problem very intensively, hopefully during our last week. Okay, now we want to stick to the interpretation, to the standard interpretation behind dual S estimator that more or less you should know, which is this one. So let's come back. So, and this is now. Econometrics, the one cluster and the one at top, okay? And according simplest model ever, I imagine that per capita consumption depends on per capita income, okay? So in that model, Y will be per capita consumption and X will be per capita income, okay? Now, what I'm doing here, I'm saying that the expected value of, imagine that this is the first student, okay? I have a cross-section of data here, my class, so I runs over students. Take the first student, so I is equal to 1. The expected value of the error term of the first student, conditioning not only on the income of the first student, but the income of all the other students, the entire class is equal to 0. So it is kind of strong, even a stronger assumption with respect to before, where we only condition on xi, okay? And by the law of iterated expectation, we know that the unconditional expectation is equal to 0. Okay, guys? And then, and this is quite standard, we know the error term in the average must be equal to 0, otherwise we are in trouble, so our model does not make sense. Now we have the following set of very, very important assumptions. Without those assumptions, we cannot estimate the model, and you realize that very, very quickly. The first assumption is that of conditional homoskedasticity. We're going to use this term, homoskedasticity and heteroskedasticity, quite intensively during our course. It's not a difficult concept. Homoskedasticity say that whatever the student I am considering, the variance, so the variability. So what is epsilon I in our model for per capita consumption would be the part of per capita consumption of my students that I cannot explain by income. Okay, so the variability of this guy, conditioning on all the income of the student, of all the students, is equal to, okay, square of epsilon, you know it's a variance, is equal to a constant, sigma square epsilon. You can see this guy, the variance does not depend on the student. My students have the same variability of consumption. Is it a reasonable assumption or not? Just what do you think about? I mean, is it reasonable that the students of applied econometrics have the same variability of consumption, their per capita consumption?
Yes.
Yes. Why?
Because we have here without we are random, a random group of people.
Okay. Okay. The argument of your colleague is like this. It's very interesting argument. He said, there is no systematic, applied econometrics is not attended by rich students can be attended by, I mean, regardless of the level of income, more or less. People just join applied econometric RESD master program just because they are interested in resource economics things. So you are quite similar from the point of view of consumption behavior, more or less. And so it's not that unreasonable assumption. Someone else could say, well, come on, if you study seriously your class, there will be those who have more, that spend all their money, just they do like aperitivo, blah, 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 all the times. There are other students who save the money. So it's quite unreasonable assumption. We don't know. We are putting this assumption, almost the same variability, and we find a way to check it, to test it, okay? But, you know, if we relax homoscedasticity and we go for heteroscedasticity, I should have 60 variances. In this case, under homoscedasticity, I have just one variance. Okay, and you know it's an incredible reduction of number of parameters to be estimated from the data. It is an hypothesis that we make mostly for convenience. But imagine that I know that in my class there are two groups of people. Imagine that for some strange reason, the people at home and the people in the classroom have different variability of consumption. It's something that we should take into account. So in that case, we have heteroscedasticity, because the online people, it's just I'm saying an absurd thing. But imagine that for some reason, online people have different variability relative to in-person people, and in that case, we have at least two groups of people. Okay, but with this assumption, we just say that there is we have just one variance. Okay. In some cases, can be reasonable. For instance, our example. In other cases, it is not necessarily so. That's why that will be one of the checks we have to make to our model. You'll see that when we go with the OLS estimation, we are making this assumption. When you push your button OLS, you are saying that in your data there is homoscedasticity. So one of the check before, in order to check whether our model is good or not, one of the check we do is whether homoscedasticity is supported or not by the data. I don't care about the R-square of the regression. I care about the conditions behind OLS. And now you will see that that is one crucial condition behind OLS. The second assumption is that, say, the covariance between the error regarding student I and student J, conditioning on all per capita income by student I and student J is equal to 0. So there is no, basically the error term associated with student I has no interaction with the error term of student J. And this, in this setup, seems quite reasonable. I don't know, unless I have some strong argument to say, well, the error term of student I has something to do with student J, I don't know why. So this is the hypothesis of no conditional correlation. And of course, let me think, if you have a group of n people, if n, small n is the number of students we have in the group, how many correlations do we have? We have basically n binomial 2, right? Do you agree on that? N binomial. N. Can you tell me if you know binomial? The engineer is attending from home knows what is the binomial formula. Also, mathematicians know that. I don't know how to make equation formulas with this. Inserisci, thank you very much. Inserisci. Però you know so what I'm talking about. No, you don't. Okay, okay. Okay, good. So I double click. Oh, okay, maybe it is here. Okay, I should find something here. It's not an operator. Maybe among the parentheses. I don't think this is maybe like this. So I have a group of n people. How many couples can I do? And of course, the ordering, say the group, say 1, 2, is the same as from a point of view of 2, 1. Okay, guy number 1, guy number 2 is the same as. So how many people do we have? N factorial, 2 factorial, n minus 2 factorial. Okay, do they say from the phone? Can you see a Tom?
Not really.
No.
Doesn't matter anyway. It's not important. This is just okay. This is just to say this is the number of say elements that you can get from the. Let me put it here. Okay. Now, important point, of course, by the law of iterated expectation, I promise that we are going to use it in an intensive way. Now I change the camera. I will stay seated for a while. So this is audio. Where is video? Okay, thank you. Should be before, right? Okay. Okay, so by the law of iterated expectations, all the time I use this. If we are assuming conditional homoscedasticity, so if we have this condition here, the one I'm touching with my hand, then by apply the law of iterated expectation, we obtain also unconditional homoscedasticity. So this is why I already gave the answer. I'm simply applying the law of iterated expectation and I get this result. So also unconditionally, the variance is the same across units, across students. And by the same trick, by the same argument, so if I have unconditional correlations, so if I have this condition here, by applying the law of iterated expectation, I get also this condition unconditionally. So what we did was we made an assumption of conditional homoscedasticity, and we get also unconditional homoscedasticity. We made an assumption of conditional zero correlations, and we get the we obtain also unconditional zero correlation. What was the tool we used? Just the law of iterated expectations. Very simple thing. Now, so we have a linear regression model now with more information. It is our linear regression model. Now we have homoscedasticity and correlation. Now those are two assumptions are crucial in order to simplify the model, because now how many parameters do we have in our model now? Which are the unknown guys that you want to estimate from the data? We have the beta guys, the beta parameters, and we have k elements in the beta vector. One convention. When we have a constant in the model, do you remember in our in exercise we have beta 0, the constant, okay? When we have the constant, the convention is that we are including 1 among regressors. Why? Just think about the other product. So if I have just, when I touch this guy, I get, this is a beautiful room, but very not, I don't like it. So I have to start again. So how many registration do I find this time? More, 3.
In your product folder.
Yes, so I have to put all 3 on.
You can also add it at the end. So put all the 3 registration to the end, all together, and just upload just one on the list one.
Okay, I'll see if I can do that. But okay, so your point is that I can upload, say, like all attached. Thank you. Okay, thank you very much. So I have to pay attention to this. I don't have to touch this stuff here. Okay, so I wanted to point out this expression here, just to say to you that imagine that you have a constant in your model. This is, this outer product between regressors and beta. Imagine that the first guy here is just 1. So it is a deterministic regressor, not a stochastic one. You have constant and plus all the rest, okay? So we have the convention, coming back to our setup. The convention is that we have, this is the setup, okay? We have, say, among xi, we can have also the regressor 1, which is the one associated with the constant. Okay. Now, how many parameters do we have in this model? K slope coefficients, the betas, okay? And as I told you, we assume that beta include also a constant. That is, the vector of regressors, xi, includes 1, okay? 1 as of its element. And then we have just one variance, 1 sigma square. Sorry, I missed epsilon here, but it's sigma square epsilon, okay? So we have K slope parameters and 1 variance. The covariants are 0 by construction. So at the end of the day, we have, say, K plus 1 parameters in our model. And the one important condition is that, so which is the first, say, the first necessary condition we have to meet in order for the model to be estimated from the data? If we have small n observations, we need that small n is larger than K plus 1. Otherwise, we have less observations than parameters. We are in troubles in that case. So it means that, yes, you can have a model with large number of regressors on the right-hand side with large K, but pay attention because K plus 1 cannot be larger than the number of observations. Let me say, have you ever heard about learning machine methods, big data, blah, 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 which are very in fashion today? So one of the among the class of learning method, learning machine, blah, blah, there are regression models where you have, say, a huge number of regressors. So xi is a very large vector, and you find method for estimating beta such that you shrink some of the parameters, but it's nothing mysterious, nothing. It's very simple thing, okay? And let me say that you may also believe that the more regressors you put in your model, the better your model. Just forget about it. I don't belong to that. Maybe for forecasting purposes it can work, but when people do like this, it means that they don't have a clue. They don't have a theory about. And what I don't like about learning machine things is that you may have the impression that the data can tell you something without having a theory about the phenomenon, the problem. And from my point of view, that is very, very dangerous. Always have a theory, and of course, the theory will be subject to scrutiny by the data. That's the way I interpret the work of an econometrician. Okay. Anyone is able doing learning machine things using data, blah, 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 in order the data must tell us something. Yes, the data are very important. They tell very important things, but if you don't have a theoretical view, even competing theories, it's fine. But you do need a theory, okay? Anyway, this assumption simplify the number of parameters to be estimated. We'll see that later on. Now, I want to, before the break, then we make the break, I want to come to matrices now. Because why do we need a matrix form representation of the linear regression model? Because it is very useful now compacting the model we just saw in matrix notation. I do that not because I am a bad, nasty person, just because we need it, just because it will simplify our life sometimes. So the matrix notation simplify the understanding hypothesis behind the model. And now follow me quite. So this is our model, okay? This is our regression model. The index I runs from 1 to n, okay? N is the number of observations. They can be individuals, cross-section data. They can be time series data, okay? Now, take individual number 1. Take the first student. What is this model? This model becomes like this. Take the second student. What is my model? The model becomes like this. Go on. Take the last student of my class, and the model will be like this. So nothing special up to this point. Now, it is very convenient. Think about now the left-hand side. I have per capita consumption of the first student, per capita consumption of the second student, per capita consumption of third student, blah, 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 per capita consumption of student n. So it is very reasonable to stack per capita consumption in this vector, n by 1, okay? Now, I go back. Think about this guy here. This is since you have prime here, we are transposing, this will be a row. You agree on that? X1 prime is, imagine that my consumption, per capita consumption model for my student includes a constant and income of the student. So in that case, X1 for the first student will be a constant 1 and per capita consumption of the first student. What about X2 will be 1, there is a constant, and per capita consumption of the second student. And so on, so on, so on, until last student, there will be 1 constant, and there will be per capita consumption of student n. So it is very convenient to put all these x1 prime beta, x2 prime beta, blah, 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 to put together in the following rows. Okay, those are, okay? And let me go back. It is even more beta is always the same. So this will be row, and you understand that this guy I'm selecting with my hand will be a matrix with how many rows? N. How many columns? How many columns? Sorry? No, one, K, because I have K.
One column.
No, not one column. Look, I mean, if there would be no prime here, yes, that would be a column, but those are rows, rows, rows. So you have columns, K columns. So the X matrix you find here, I call this guy I'm selecting in my N, X will be N by K. The beta, I just put, this was moving from here to here was just algebra. And beta, it remains K by 1. Finally, what about error term first student, error term second student? It is a vector. I call it epsilon, N by 1. And this is, you know, in this way, imagine that I say, no, guys, forget about Stata, forget about, how many people do use Stata in this? Do you know Stata? Just one? Okay, some people know Stata. It's, you know, I'm joking. Stata is my enemy. Just because with Stata, the problem I see with Stata is that you have many things, you can do many things with it, and if you haven't a clue of what you're doing, you do mistakes. Many. Also, so-called expert people. Okay. This is a joke, of course. Stata is fine, it's good. I prefer a little bit Gretel because Gretel is more teaching oriented, as you will see. And I promised we are moving to Gretel at a given point. So don't. So I was saying that I lost my point. Okay, imagine that I say forget about Stata, forget about Gretel. I give you MATLAB. What is MATLAB? For instance, MATLAB is a matrix-oriented program. One thing, just one, when you graduate and you make your job interview, and they will ask you, okay, which package do you know? Do you use other than Office? You have to know Office, but do you know any language program? Well, we just used Stata, a little bit of Stata, a little bit of Gretel. Don't do like this. You say, I can use anything. Just ask me, give me 2 days. No, give me just 24 hours, and I will be an expert of the package you want. Do you want SAS? I will be an expert of SAS. Do you want MATLAB? I will be your expert of MATLAB. Or do you want whatever? I'm very flexible. I'm very ready for. Don't say, well, I just used that with the course Professor Dieci was using. No, just forget about that. You are expert of a matrix, any package, any software it is important for your firm, okay? So imagine that you say, I give you MATLAB, you can download, as a UNIBO student, you can download MATLAB for free. You have a license. And the MATLAB is a matrix-oriented program. Imagine, say, your objective at the end of the day will be, you have to estimate beta. I want to replicate. You have to replicate with MATLAB the output provided by Stata. So the first thing you have to do is to write this column Y, because at the end of the day, you will see the OLS expression of beta is, let me go on. I want to show you beta will be something, the OLS estimator is this, where is it? Here, wow, look at it. At the end of the day, I have to compute this expression. So you understand I need the Y column, I need the X matrix, and then it will be very, very easy going for MATLAB computing the X prime, X inverting a matrix. It will be and multiply X prime Y. You get the same column that you get by when you push your button in Stata. So why I say so, and then we stop. I say so because working on the matrix representation of the model really makes you understand what's going on in your model. Okay, so coming back, I want to just then I stop. Want to push on this. This is not a single column. This is a row. This is a row. This is a row. At the end of the day, you have a matrix with many columns, and the columns are k, the number of regressors. So, question, just to check whether you're understanding. If I have a constant in my linear regression model, what will be the first column of this matrix X? Someone unmuted the microphone, go on. So I have a constant in my regression model. Let me go back. Okay, imagine I just said, if there is a constant, the first element of this vector will be 1. Okay, so look at here. What will be the first here? What will be the first element of this row vector? Will be 1. What will be the first element of this row vector? Will be 1. So you must see that the first column of the X matrix will be 1, 1, 1, 1. The second column will be observations over n individuals of the second regressor. Imagine, for instance, income, okay? The third column will be observations across all n individuals of financial wealth. It's not difficult, guys. Okay? We make a break. According to my PC, it's, where is the time? Oh, I have some question from the, okay, no question. Okay, to my it's 4:03. We make a 10-minute break, so we start at 4:13. Okay, so I write it on the chat. Ok, vediamo un po' se è così. Vediamo. Oh.
Adesso dovrebbe...
Ho detto prova.
Sì, perché vede le lineette verdi del microfono.
Vanno. Sì.
Che vanno. Però ecco, potrebbe non trovarle nella... Cioè, ad esempio, se adesso vuole fare una prova
sì.
e cliccare su stop della registrazione,
sì.
le si apre una finestra. Ecco, qua dice, lei dovrebbe mettere fatto per salvarla.
Sì.
Se prima magari non ha cliccato
La prima l'ho eliminata, mi ricordo.
Ok.
La seconda non lo ricordo.
Quindi questo magari mette fatto, così la prima parte della registrazione è sicuramente... Ecco, infatti... queste sono 2.
Quindi ne ho 2.
No, ecco, tutte e 3.
Ne ho tutte e 3, ok.
Tutte e 3.
Quindi io potrei addirittura riprendere questa qui.
A questo punto sì.
Posso riprenderla con questo.
Magari una volta che sistema il microfono, a questo punto...
Bene, però sistemare il microfono a questo punto non riesco a capire perché non becca il microfono.
Ma forse c'è qualche problema proprio il cavo che a un certo punto non... Perché è come se usciva proprio l'USB, cioè come se il device a un certo punto venisse staccato.
Purtroppo qui se tocco si stacca tutto.
Tanto... Adesso in realtà le sta processando tutte e 3, perché quando saranno al 100% lei le potrà...
Le posso caricare, sì, questo, quindi io le caricherò tutte quante e quindi trovate su virtuale tutte quante.
Okay.
Tanto il nome c'è, 16,
sì.
Weden 16, ok.
Non sono separate.
Però io sono preoccupato sulla qualità della registrazione, a questo punto con le aule così grandi mi sembra che non... Cioè io non ho mai avuto, quando l'ho fatto con laptop, da quando eravamo proprio in pandemia da casa, con laptop, mai avuto problemi di questo tipo qui con Panopto. Non so se è dovuto al fatto che c'è il microfono unidirezionale, questo qui che...
Ma no, intende della lezione di lunedì?
Sì.
No, quello è perché appunto non erano connessi i microfoni tra Teams e Panopto.
Ah, ok, per quel motivo lì.
Per quel motivo non si sentiva.
Ok, va bene. Va bene, grazie comunque. Prego. Prego.
È una cosa molto semplice, ma non ho capito ieri. Come mai quando abbiamo la conditional expectation così possiamo portare fuori questa
Sì, perché è come se lei stesse, le faccio l'esempio, come dire, immagina è come se l'avesse congelato,
sì,
condizionando, è come se x fosse congelato, condizionando il x come se l'ho fatto diventare una costante, e quindi la posso tirare fuori. Condizionando è come se io ho detto, tu sei una costante per me, tu sei data, essendo data non è più la variabilità, avendo condizionato rispetto alla x, tu non sei più una variabile casuale rispetto all'x, ma sei data rispetto alla x. È un'intuizione.
Perfetto, non avevo capito questo punto. Grazie.
perché io sono il ponte tra le tedesche. Sì, esatto. Anch'io.
Prof, io ho mandato una mail a tutti, così, cioè mi sono gestito con Mazzaferro e le ore.
Beh, i docenti SFA? Oh,
Sì,
okay,
cioè, ovviamente sarò disponibile in quelle ore, che poi rientro anche la sua lezione,
grazie,
se ha bisogno mi scrive.
grazie.
E un'altra cosa, ma cioè, quando lei ha detto che c'è la costante,
Sì.
quella riga praticamente va vista come una serie di righe, cioè elementi di una riga, e poi per ogni elemento guardiamo una colonna.
Se c'ho dove l'esercizio, allora faccio un esempio. Faccio un esempio con col Word adesso. Okay, I start. I try to. Provo con riprendi. Okay, so we can start again. I hope the audio works here. Okay. Okay, now I have some interaction with some colleagues, and I realized that I have to come back on the matrix representation. I'll try to do an example, because this must be very, very clear. And when you don't understand something, please, you better tell me, okay? Otherwise, we go on and it gets very complicated. So you better say something. So imagine that we have just small n. We have modeling 3 countries, okay? For my model is like this. I have CO2 emission in country I probably I can put it sub. Let me increase the. Can you read it? Also, the guys at home. Are you follow me, guys? It's very difficult to check whether the people at home is.
Yes.
Oh, okay. Thank you very much. Please interrupt me if you have problems. So my model is like this: CO2 emission country I depends on a constant. Plus, according to my model, this is not a very sophisticated one, beta 2 times I have GDP say, per capita of country I. So very, very simple model, plus epsilon I. Okay? This is my model, and I have first question, how many parameters do I have in this model? So I have, say, how many regressors? K is equal to 2, because I have constant and beta 1. Okay? And then, under the assumption of homoscedasticity, I have plus 1. I have, say, one variance. Sorry. Oh, what is that? So at the end of the day, we have 3 parameters, okay? We have beta 0, beta 1, and, say, sigma square, okay? Where is the variance of epsilon? Okay, well, but where is, this is also the keyboard is not, oh, okay. So the parameters are, let me write it extensively. So I have beta 0, beta 1, and sigma square. Let me assume that the parameter, the countries actually are 4. Otherwise, we were in the situation where we had 3 parameters, 3 countries. We can still estimate the model, but you know. Now, this is the, say, the representation with the index I. Now I want to go to the representation, this one, the matrix form, which is y, okay, isn't that? Y is equal to x beta times beta plus epsilon. How is defined y? The exercise is, what is y? What is x? What is beta? What is epsilon in this model? Okay. Now, what is y? Y will be, now you can follow me. Y will be a vector including CO2 country 1, CO2 country 2, CO2 country 3, CO2 country 4. That's it. Now, what is x? Before, what is beta? Beta is the vector, is the 2x1 vector, where we have beta 0, constant, and beta 1, which is the parameter associated with GDP.